Hello, everybody. This is Holger Kenn. I'm representing the OPC UA for AI working group. And Stefan, thank you for the kind introduction. And I think this fits very well to what Jim just said regarding the ability to actually run AI on the edge, because that is also something I'm going to touch a bit later. So what I'm going to talk about really is that we have a working group that works on generative AI and OPC UA and the use of the one for the other. But I want to get a bit more into detail and say, well, what can we actually do with this? And you've probably heard this a couple of times over the last years, but let me just give you a real quick introduction on the way how I see this whole generative AI world today. So when you hear about generative AI from a technical point of view, you're actually talking about a stack of different services, right? And you have applications, and ChatGPT comes to mind. But you also have AI infrastructure. So this is when people think about the large GPU-powered clouds, but also things like edge devices that sit somewhere close to where the action is happening. You have the individual models, language models, multimodal models, you have very large models, you have small models. And this is all the complexity that you have in this. But to really simplify things, in the end, this is all about the end users that want to have a problem solved, the developers that want to build tools and services for those end users. And in the end, a lot of this is all about data. And where OPC UA comes in is the ability to provide data. So let's think a little bit on what kind of data is involved in these generative AI systems. So you've probably heard about all this harvested public training data, the things that are on the web that people have downloaded that try to build these AI models based on this public training data. But there's also a whole world of exclusive training data that is very specific to applications, that is very specific to specific domains, to also from a legal point of view, there are certain areas where data is not just widely available, but it's licensed and then it's used for specific purposes. And there's another world which we call synthetic data. So this is basically data that's specifically generated to build AI models. And what OPC UA offers is mostly actually contained from the standards point of view in the public training data, because there's just a lot of information out there about OPC. So kind of by accident, a lot of the today's state-of-the-art models have some idea of what OPC is and what it's good for. They're not specifically trained for OPC UA. And the ambition of that working group is also not to create a special AI model for OPC, but more to provide technology so that you can use the existing models in the combination with data that comes from the world of OPC, be it specification, be it data from the OT world. So the first thing that you may have heard about is called retrieval augmented generation. And this is basically where we don't need to modify a model, but we can actually augment the model by giving it additional information. But then most recently, and especially in the context of agentic AI, there have been some new ideas on how can you actually provide live data to the model so that the model can actually decide, oh, I need some additional information. Can I use this? And these top two boxes are really the ones where OPC UA can play a role. So how can this work, right? The idea here is that we have data models. We have what we call semantic interoperability in OPC UA. So basically something that tells us what's actually the data, what does it mean, what can it be used for, how accurate is it? But then we have the actual data that comes from a running system. This could be a factory that provides its data. And this is really the data that would give those generative AI models to actually work with. So these are the two things. But again, what is this model context protocol? It's called a protocol. And what's this other thing? So I don't want to read this whole slide, but just to give you an idea, the idea of retrieval augmented generation is there is information missing. There may be information that the model knows about, but the information that's needed for answering a very specific question may be buried deep in the training data set of a model. So instead of hoping for the best and hoping that the model just finds this, we can just throw in additional information when prompting a model. We can just give it the text. Now, what text is relevant, that is also something a model can help us with. We can basically ask a model with specific ways to query data, like databases or like so-called vector databases that are a specific way of querying this data. And then we just take that data and give it to the model. And now the model is informed. It knows this information. Now, the model context protocol is a little bit of a different thing. So here the idea is we're not telling the model straight away that this is the data, but instead we tell the model, by the way, if you need data, here's a tool. This is the way how you can invoke the tool. And now we take the input of the user, we give it to the model, and then if the model decides, oh, using that tool would be helpful, and this can be as simple as a digital calculator that can do calculations, but it can be as complex as a tool that can actually pull live data via OPC UA. And then the model decides, oh, I need this additional information. It invokes the tool, the output of the tool gets thrown back to the model, and now the model is informed. So there's been a bit of confusion on what is MCP. It's a protocol. Will it replace OPC UA in the future? Is this the next generation? So first of all, Stefan, I hear you. No, OPC UA isn't just a protocol, right? We all know that. Now, MCP is also not just a protocol. It's kind of an API definition. It's a transport protocol for one specific thing. Let's say you have an AI application, something like a copilot that helps you with something. And now that copilot needs to go and invoke a tool. And that's exactly what MCP does. It basically tells the application, here's a tool, here's some reference information, here's a good prompt that you could use for solving this problem. And that's all contained in MCP. MCP, however, in its main idea, is not a remote protocol. It's more of an IPC mechanism between a local application and a tool that also runs locally. So the simplest transfer, therefore, is stdio, which basically means you're controlling input and output of just a command line program running. However, there is a similarity because MCP doesn't just define the protocol, but it also has a way to define the semantics of a tool. So essentially, MCP gives semantic interoperability for generative AI. And so that may actually be really the fundamental relationship here, that MCP tries to solve a similar problem. So how does OPC UA help in all of this? Well, the interesting part here is just the breadth of information that is available in some form to OPC UA. And the most important aspect of this are the companion specs, because those companion specs actually not just contain the way how OPC UA can be used in the domain, but it also contains a lot of domain knowledge. It basically has the information on how people in a certain domain would actually go and talk about a certain thing. And like we've just heard with the railroads, I mean, this is something where the technical people operating railroads know a certain terminology, and having an OPC UA companion spec for that domain basically means that when you're using the domain-specific terminology and you call something a switch, then, well, it's probably not an electrical switch. And that is really the bit where an AI system can be informed. So this is basically the bit where OPC UA comes in. Once you have the production data and the data models in OPC UA, it means suddenly things will get much, much easier. So what do we want to solve with this? So number one is probably something that you've heard already, AI in engineering. Well, this could be for software engineering. This is probably what's most popular right now, but also many other engineering use cases can really be supported by using AI. And I think about going through documentation, reading specification, reading documents that define domain knowledge, like domain-specific handbooks, but also like the companion specs. But it can also be used as an analysis tool of brownfield systems. So when we have this information in some form of documentation, then an AI model can actually go and help us read that and extract information and use that information to build something new. And that gives kind of one of the more obvious ideas is, well, a lot of the code that people that especially interact with brownfield systems, they need to write is based on information they need to retrieve somewhere. And this is really the bit where an AI system with a standard that specifies how the device actually works basically allows us to just generate a lot of this code instead of manually basically finding out all these things, provided the information is available. But once such a system is running, there's another important application, that's data analysis. Because now we have OPC servers running, they're providing data. And now instead of having a domain expert and an OPC expert and maybe a database expert all working together and saying, well, let's build this custom analysis, we might actually get to the point where we can just ask questions in language. We can basically say, hey, what is actually going on in my system? Why is my system failing? And now that is really the interesting bit, is that instead of having kind of this extra team that helps you do the query, the domain expert can just use natural language. And then the next thing is really, how can we empower people that are sitting in front of the machine, that are operating machinery in that moment? And this is really the bit where we can combine all the capabilities and we can add the agentic component of AI, where essentially now we have a tool and machine operator can talk to and just investigate, ask questions, get information, retrieve information from documentation, and then up to the point of actually being able to do fault and root cause analysis, just based on his own knowledge of the domain and the information that is available to the AI models. Okay, let me just take a few seconds here to give you a little bit of a demo. So how could we ask about data? But now let's say we're not in the world of the cloud. We have a physical device that's somewhere. We don't really have a connection to a backend system, but can we actually use something that sits on rather small edge devices and comparable to the devices that Jim just mentioned in his talk? These could really be powerful AI-enabled edge devices. And how could OPC UA help there? So some of you may have seen my talk at Hanover Fair. So I've changed the setup a little bit here in actually using two devices. So I've split this into a simulated OPC world. I'm running this on a Raspberry Pi. And that's basically the OPC Foundation IIoT PubSub demo that I've just downloaded and just run locally. And then I've added an AI-capable device to it. So in this case, this is NVIDIA Jetson Xavier. This is clearly not the most recent model. There are much more powerful devices today, but this is kind of what I found on my workbench. And this is all just put together locally. And I just want to run a simple question against the data that comes out of this. Now, the important part is that, and you see that in the PubSub demo, the information that's sent to the MQTT broker is in an OPC-specific format. So it actually contains both metadata and the actual data from the simulated devices. And that's really something the AI models can make use of. So I create a very simple prompt. And as you can see, there's not really a lot there that is OPC specific. It's even not a lot domain specific. I'm actually just doing one little hint, but I'm basically saying, hey, when you look for something that's a pressure, then it's probably in the unit Pascal. And then I just ask a question. What's the largest pressure of the boiler at the Riverdale site? So I've recorded this before but it was just a few minutes before I gave this presentation. So here you can see we're actually running the cloud demo, and this is the information that's sent out. And what this demo basically does, it just pulls metadata and data from the MQTT data stream, and now takes this information and just adds it together with the prompt to a model and sends it. And that's a very small model. It's a 1.5 billion parameters DeepSeek model. So this is really comparably small and can easily be run on embedded devices on the corner. So I'm going to forward this a little bit so they don't have to wait for about 1 minute. I'm just going to skip here. And this is actually the time it takes on these actual devices to pull such an information. And here you can see down here, it recognized it has found the boiler pressure to be 5,000 Pascal. So how did that work? So this is kind of what the model actually said. And it's a model that is basically following its internal thought process. This is what you can see with this little think tag over here. And so it basically starts reasoning about the information it found. And that goes on for a while. And then it actually provides an answer. And this is really short. And this would be the answer you would give to the end user. So this is a very simple idea. This is also rather brittle. So this doesn't always work every time. There's probably some additional information we need to use to augment this system with additional information to make it more robust. But it basically shows the way, even what you can do in a very simple way based on the power that the semantic information is actually contained in OPC-based data. So just a little report on what we're doing in the AI working group. Today, we have 73 members. It's open to all the OPC Foundation members. If you really want to influence this area, then maybe that may be a reason for you to actually become part of the OPC Foundation and collaborate with us. We also have really members from all kinds of organizations from all over the world. So from small companies to large enterprises, including folks from academia. Fraunhofer is super active here. It's excellent, the work that they're doing. And also we have folks coming from other industry associations really looking into this. And it's also a way to just learn about this technology and understand how you can actually use it and how we can actually further the goal of combining AI with this semantic interoperability that OPC already provides. And that's all. Thank you very much.